Okay, can you guys see this? I need an answer from you. Can you guys see this? Are you guys able to see this picture of the question? Okay, cool. Now, the question says that we have an alternating current passed through an air core solenoid, and an iron core is inserted into the solenoid and then held stationary within this thing, and the current in solenoid is now smaller, right? So explain why the current in the solenoid is reduced as a result of inserting the core. This is a hard question, so we're going to start discussing it right away. Now I'm opening up the whiteboard now, and let's start discussing it. So what happened here was I took this coil, right? So I took this coil. So let's make this coil. I took this coil, 1, right, 2, 3, and 4. I have this nice little coil here, and I have an alternating current. I hope you guys know what that means. I have an AC current. This is not DC. DC is this. This is DC. Right? So this is DC. This is AC. Right? So I have AC current here, and I have a south pole here. Right? This is my south pole. This is the north pole. And what we've done here is we have placed an iron core inside this coil. Right? So let's place it. So we have this nice little iron core here. This is the iron core. So as a result of placing this iron core inside this coil, the current suddenly got reduced. Now I'm going to write 2 reasons. You just have to note them down and you have to understand them. Let's start explaining why this happened. All right, I'm going to start typing now. So note it down. All right, explaining the first reason. When the iron core is inserted, the inner core experiences an induced EMF. So when I insert this iron core, right? So when I insert this iron core, the inner core experiences an induced EMF. And this EMF opposes the supplied EMF. What is the supplied EMF? Supplied EMF is this one, right? So this is the supplied EMF. So this supplied EMF is in the opposite direction of the new EMF that is coming from here. And because these two EMFs are opposing each other, there's a net reduction. I'm going to explain it further, so don't worry if you don't get it now. All right, let's look at the question again. The question says that an alternating current passed through an air cored solenoid. An iron core is inserted. When they say air core, this means that there's nothing inside here, right? So now this is the solenoid. So this coil is the solenoid. And inside the solenoid, we have placed the iron core, right? So iron core has been placed into the solenoid and held stationary within the solenoid, right? So it's not moving, it's in there. That's it. Now, the current in the solenoid, meaning the whole circuit, the coil, right, is now smaller. What happened was, let's say before I had a particular value of current, right? Now pay attention because this is important. If you don't listen now, you're not going to get it. Now, be very attentive. I had a current before when I did not have the iron core inside, right? So this is the iron core. And when I did not have this iron core, my current was normal, right? So let me use a brown color to write down the name, right? So this is the iron core, right? So when I did not have the iron core, everything was okay. But when I placed it inside, the current reduced. And they're asking us, explain why the current in the solenoid is reduced as a result of inserting the core. Now, when the iron core is inserted, all of this is the explanation, right? So the inner core experiences an induced EMF. And this opposes the supplied EMF to the outer core, right? So when I placed the iron core inside, the magnetic flux changed, right? And as a result of that, I had an induced EMF. Now, obviously, by Lenz's law, right? So we placed the iron core inside, and now something is going to happen that's going to oppose the change, right? So this EMF is going to be in the opposite direction to what we had here before, right? The one that was coming from here. So these two EMFs, because they're opposite, right? They're gonna oppose each other. And obviously, I mean, if I had a greater EMF here, now I have a some kind of EMF here, 5, 1. So 5 - 1 is 4. And oh yeah, so 5 - 1 is 4. And now I have a lesser EMF. That's it. This is what it's saying, right? So because of the iron core inside, the flux inside the iron is maximized, right? So because of the iron core inside, the flux inside, this whole thing, right? So inside the iron is maximized, maximized, right? There's another concept that you guys did in O levels, which was the shielding effect, right? So if you have an iron or something, right? So what's going to happen is the magnetic field is not going to reach the inside of it, something like that, right? This is an O-level concept. I can give you a little recap in the next class, but because of the shielding effect, right? So the outer coil, the flux, right? So in the outer coil is reduced. And because the flux is reduced, when we place the iron, basically, because of shielding effect, the effect of magnetism reduces, right? So because when I have an iron, I can reduce the effect of magnetism. And when I placed this iron core inside, this magnetism or flux reduced, right? And that's why, as a result of that, current also reduces. These are the two reasons. Just try to understand them for now, right? Now we're going to do the next thing. If you open the past papers, a lot of the questions are just going to be explanations for different phenomena. I hope you guys have taken a screenshot or noted this down, right? Because I'm about to erase this. All right, I'm about to clear this up. I hope you took a screenshot or something. All right, so note, right? We have a little note here. In numericals, right? So in Now we have a coil here. So I have a coil here, right? And the coil looks something like this, right? It looks like this. This is plus, this is minus, right? So I have some voltage here, right? And we're moving it back and forth, the magnet. So when you move it once, there's going to be some EMF induced. When you move it twice, there's going to be an EMF induced. So if you keep moving this continuously, only then can you have a continuous supply of EMF inside. If you just move it once, right, let's say from R to L, you cannot expect a continuous change. There's going to be just a little change in the galvanometer. That's it, right? So tell me one thing. All right, I need an answer. When I move the magnet towards the coil, I get some kind of EMF. Let's say like this, right? So let's say I get this, right? So I got some kind of EMF inside, right? Now, this means that I have changed the flux once. When I move it away, I change the flux another time. So I am cutting flux two times, right? I'm cutting the flux two times. As a result of that, I'm going to conclude that a formula is going to be 2 phi divided by t. This is E 2 phi divided by t. So when you have a question where you have the flux being cut two times, it's going to be 2 phi, right? So cutting flux two times. Right? I hope that made sense. All right, let's minimize this. Any confusion so far? Come on, guys, wake up. Any confusion so far? Did everything make sense so far? Okay, that's cool. Right, that's great. All right, let's do the generator. Right, the generator. It's the generator, right? So we have a North Pole here. We have a South Pole here. And I have a nice little structure of a circuit, right? So I have a circuit here, and the circuit looks like this. Right? This is an O-level concept again. So if you are weak in these things, make sure you revise O-levels. That's the only way you can succeed at the moment. Make two circles. These are those concentric rings. We're not concerned about how they work in A level, but it's always good to have uh, everything revised, right? So like this, and we have a bulb here, right? So we have a bulb here, and let's make a dotted line, right? So make these bulbs a little smaller. I kind of overdid on the size, right? So it's going to be like this, right? So yes. Now, when this thing is rotating about this normal line, it's obviously going to cut the flux as well, right? So I am cutting the flux as well. So the flux here is going to be phi is equal to VA, right? And the flux linkage is going to be NVA, right? So this means that the number of times I basically do this, right, multiply by VA, and that's going to be the flux linkage. If I make the graph, it's going to look like this. So the graph is going to look like this, and here we go. It's going to start from here, and it's going to go all the way down there, and it's going to come back up. It's going to be a cos curve. I made it in a bit uh, in an untidy way. Make sure you make it in a better way. All right, so synthesis flux, right? And we know now that there's two types of flux, right? We can have flux in opposite directions. So this is going to be NBA, flux linkage, I mean, and this is going to be minus NBA, right? So in two different directions, because this is a vector quantity, right? And this is time. All right, and that's pretty much it. Now we're going to make another graph. So I'm about to erase. Okay, note this down when you're done. Tell me so I can erase this. So when you're done noting this stuff down, tell me when you are done. Okay, great job. Now let's make another graph. Now the second graph is going to look like this. We just have a little stuff to do, and that's it. I'm sure you guys are exhausted after such a long lecture today. But yeah, we got to do a lot of work now. Anyway, so this graph is going to look like this. So this is going to be EMF. This is going to be changing. This is going to be time. Now, before I had NBA, right? So NBA. Now we're going to have NBA W. It's NBA omega. So I'm going to show it like this. Right? So it's going to go up. This is going to be a sine graph, right? And this thing, if we translate the previous graph over here, based on the calculations, this is going to look like this. So NBA omega, right? So NBA omega. And this is going to be NBA omega minus, right? So this is minus NBA omega. And this is NBA omega. And I finally have this formula, which is E is equal to NBA omega sine omega t. So this is something similar to what we did in SHM when we did the graph for displacement and velocity. And finally, one last thing, that is this. Max EMF is going to be equal to E is equal to NBA omega. And that's pretty much it. That's it for today. We did a lot of stuff today. Inshallah, I'm going to see you guys tomorrow. And we're going to finish electromagnetic induction since we have literally next to none stuff to do, like really less. Tomorrow we're going to finish this and we're going to do an example question. And yeah, we're done with electromagnetic induction. Anyway, I hope everyone is clear about everything so far. Are you guys with me? Okay, that's great. So have a nice day. Allah Hafiz, and see you tomorrow. Bye bye.